Hi friends! After a successful session on Bluetooth controlled robot, here I am back with another episode of DIY Robotics under What's Your Hobby? Have you wondered how appliances like TVs and air conditioners follow instructions given via wireless remote? Today, we'll learn about infrared sensors. An infrared sensor or an IR sensor consists of two parts, the LED IR emitter and the photodiode IR receiver. So what is a photodiode? A photodiode is a semiconductor diode which, when exposed to light, generates a potential difference or changes its electrical resistance. And what is an IR LED? An IR LED is a solid-state lighting device that emits light in an infrared range of the electromagnetic radiation spectrum. Used with infrared cameras, IR LEDs can act as a spotlight while remaining invisible to the naked eyes. So my friends, this is how an infrared sensor looks like. So let us know about the common parts of this sensor. Starting with the IR emitter. So this is a light emitted by the LED. The IR receiver receives the signal from the IR emitter. The VCC is the power supply. The GND is the ground pin and out is the output signal. An IR sensor is an obstacle detection sensor. It can detect an obstacle from up to 10 cm to 30 cm away. This sensor has many indoor applications. The basic idea is to send infrared light through IR LEDs, which is then reflected by an object in front of the sensor. Let us know the working process of the IR sensor. The IR sensor works on the logical output of 1 and 0. If the sensor detects a reflected light signal, it will give high output. If there is no obstacle, the transmitted light will not get reflected and the IR sensor will give a low output. So let's check out how this IR sensor makes our human following robot work. So the basic structure of our robot on metal chassis is ready and the code has also been uploaded to the Arduino board. Now it's time to connect the IR sensors to the Arduino board. Now, as we have discussed before, the IR sensor has three pins. One is the power supply, one is the ground, and the other one is the output. So let's connect these three pins with the jumper wires. Now let's connect this VCC, which is the gray one, to the power supply. So this completes the connection of one IR sensor to the Arduino board. Now we'll connect the other sensor to the Arduino board in the same process. So I have also fitted the other sensor to the Arduino board, the 5V and the ground, and the output here will go to 3. Okay, so this goes to 3. So we have selected 2 and 3 pins of the Arduino board. Now we can select any pins from here, but the thing is that we have to enter the same pin numbers while doing the coding. So that is a must. Now we take these 2 double tapes and put it here in order to place the IR sensors here. Now we'll take the left IR sensor, which is connected to 2, So our two IR sensors are ready. Now let me show you a trick. Now you can see these two blue boxes on the IR sensors. Now there is a screw sort of a thing. Now if we move the screw to some direction, so these two lights will be on, and here also if we do the same thing, the two lights will be on. So this suggests that these two IR sensors are in maximum sensitivity now, and rotating it to the other direction will decrease its sensitivity. From maximum we can reduce the sensitivity of both the IR sensors. Now our human following robot is ready. Now it's time to put it in action. The Arduino file will be downloaded from the QR code, and clicking on it will open to the Arduino app. In the meantime, connect the USB port of your computer to the Arduino board using the cable which I have showed in the previous video. Now you see that this has opened. Okay, now let us know about the coding here. Okay, so as you can see, it's 2 and 3. These are the pins to which the IR sensor is connected. These are the pinholes of the Arduino board. But you have to remember that these are the pinhole numbers to which the IR sensor has to be connected. Now let us move straight towards the coding. So from here we can see that IR left is input and IR right is also input, which are the 2 and 3 pins. Now 10, 11, 12, 13 are the output pins of the Arduino, which will give the command to the motor driver circuit. Now first comes the IR left, which is high. High means that there is no response received, and low means there is response received, because the IR sensor which we are using is a low active IR sensor. So when there is high, this will not receive anything. So when both the left and the right are high, when they are not receiving any signal back, so all the pins will be at low, so this won't indicate any of the motors to move. Now when the IR left is low and IR right is high, this means that 11 will be high. So when the IR left is high, when the IR left is low, this will indicate the 11, which is the right wheel, to move. Okay, this will indicate only the right wheel to move, and movement of the right wheel will shift the robot, or will make the robot move to the left hand side. Similarly, when the IR left is high and the IR right is low, which means that when a signal is received by the right IR sensor, the left will move, which is the 13 will be high. High means that they will move in the forward direction. Okay, now comes that both are low. So when both of them will receive signal, both the motors, which is the 13 and the 11 pin motors, they both will move in the forward direction. So and other will be we can see here that 10 and 12 are always at low, because we are not maybe making any backward movements in this robot. Only the front movements are there. That's why 11 and 13 are changing from high to low, but 12 and 10 are always at low. So this easy was the coding. Now let's connect the IR sensors, and then let us upload this code to the Arduino board. Following the process what we did for the last time, we will first verify the code. So the compiling has been done. Now we need to upload this to the Arduino. So let's click on upload. Uploading is also completed. Now all the coding has gone into the Arduino board. Now let us make the setup of the IR sensors to the basic structure we have, and then our human following robot will be ready. Here is our human following robot in action. So see, when I'm keeping my hand in the front, both the wheels are moving. I have kept the IR sensor in the medium sensitivity mode. And when I'm keeping my hand on the left hand side, the right wheels are moving and it is turning to the left side. Now as I keep my hand on the right side, so this is moving on the right hand side by the movement of the left wheels. And you see again, it will move all the way forward now, just by sensing my hand. So the IR sensor is sending signal to my hand, and it is receiving the signal back to the receiver, and then it is giving command to the Arduino, and the Arduino is giving command to the motor, which makes the wheels move. So that was our human following robot. So wasn't the human following robot fascinating? You can also try this at your home. You will get all the components needed to make the robots in the Sparklebox DIY Kit 1 and 2. Log into the Sparklebox website and order one for yourself. The link is given in the description box below. In my next video, I'll show you how to make a fire detection robot. So don't miss the next episode. Like the video, subscribe to the channel and click the bell icon for latest notifications and updates. Stay happy, stay curious, and bye-bye.